Welcome back. Now we're going to look at how to read our data from files and how to convert them into a format that is usable by TensorFlow. These data files come in different formats. Text files are probably the most common. Comes out either .txt or .csv. The primary difference between the two is in how the columns of the data are separated. Pandas is a library that lets us read files in a tabular structure into something called a data frame to subsequently manipulate the structure. Let's look at this in Notebook 1. Once again, we have a notebook up on our screen. As usual, install TensorFlow. When installation is complete, go ahead and import the libraries that we need. We're going to be importing TensorFlow as TF. We're also going to be importing Keras, which is an inbuilt API layer in TensorFlow. We'll import NumPy and Pandas as well. In the line that's highlighted, we make use of it, Keras utils, to download a file from the internet and to store a reference to where that file is saved on our local system. That reference is called file path. You could see the result of that execution in the line immediately below. The file we downloaded does not have any headers. We need to level all the columns before we read the file. After declaring a list of column names, we proceed to read the file using the pandas function, read CSV. Those two lines are highlighted on the screen. The inform method will give us a summary of what was read into our data frame. We can see that we have 5 columns. We can also see that we have 150 records in our data frame. We can inspect our data frame by asking for some records. We do that using df.head, and we can state exactly how many lines we would like to see. In this case, we'll ask for the top 10 records. The output is a tabular structure with each column assigned the name that we provided when we were reading in the file. First column is an index. It was assigned automatically because we did not choose the option to leave out the index while reading in our file. We could see the type of the data structure that we have, which is a data frame. In the line where we have the mouse cursor, we subset our data frame by eliminating the last column. The reason why we did this is that the last column has names, not numbers. We can then go ahead and inspect our new subsets, and we can see that we have 4 columns all made up of numeric variables. In the last lesson, we made use of NumPy arrays, which we converted into tensors. We'll go ahead and convert our data frame into a NumPy array. You can see where we have the mouse cursor now. What we simply do is we take the top 5 rows from our data frame, then convert them using the asMatrix method into a NumPy array. We can see the output up on the screen. As usual, we can convert the NumPy array into a tensor using any TensorFlow operation. Here's a summary of what we learned. You can use Keras, .utils.getFile to download files and also get a reference to those files. You can use pandas.readCSV to open a text file that is arranged in columns. You'll get a data frame as the result. Thirdly, you can convert data frames to number arrays. Now the file that we downloaded has a column called class. This is a categorical variable. Let's look at how to deal with these in our next notebook. We have our notebook up, and as usual, need to be sure that we have TensorFlow. With TensorFlow installed, we repeat the previous operations that we did, with downloading the file using keras.utils.getFile, declaring our column names, and then reading in our data frame using pd.readCSV. Again, we call df.info to see what our file looks like. On the screen, you can see that class has a type object. We're interested in the class column, which has an object type. Let's take a look at some rows. Using df.head, we're able to see the top 5 rows. You can see that the class column has text data. Examples of these are Iris Setosa. We cannot work with the class column as it is. Last time, we simply dropped it. However, we cannot discard data in data science. What we need to do is implement one-hot encoding. We implement one-hot encoding by making use of a pandas function called getDummies. We need to pass in the data frame that we'd like to make use of, and specify a list of the column names that we would like to convert into one-hot encoding. Once that's done, we can inspect the output, and we have that as a table on the screen. You can see the last 3 columns are now the names of the values that were in the class column. To make sure that they're unique, they're all prefixed with the name of the column that they were originally in. Now, what one-hot encoding does, it simply signifies the presence or absence of a variable. And all the variables are usually mutually exclusive. What it means is if a variable is class iris setosa, then it is not any of the others. What this means is although in this particular case we had 3 classes in our dataset, we only need 2 columns to represent the presence or absence of these 3 classes. To implement that, we simply make use of the drop first variable and we pass true to it. And what that does is it removes one of the classes and removes redundancy from our data. By inspecting the top of the class, we could see that we do not have any records that are class iris versicolor or class iris virginica. By inspecting the tail, we could see that we have some records that are class iris virginica. And as a result, there are not any of the other 2 classes. This is how we would go about converting categorical variables into numeric that we're able to use in deep learning. To recap, why do we need one? Not including. Simply because we need a numerical representation. It's important to note that categorical variables do not represent magnitude, so we couldn't convert our various classes into values such as 0, 1, and 2. Instead, we had to create a new column for each value, and then indicate the presence or absence of that value using binary numbers. In the next video, we'll see how to understand tensors and dimensionality